Dear participants, welcome to fourth day of this STC. So I welcome all the online as well as offline participants for today's session.
Good morning, sir.
I hope I am audible.
Yes, sir, audible. Good morning, sir.
Yes, sir. Yes, sir. Good morning, sir.
Please someone confirm whether I am audible.
Yes, sir.
You are
Yes, sir, you are audible.
Good morning, sir.
So today we have with us Dr. Gaurav Kumar, who will be taking two sessions on very useful tools. So first tool he will be talking about free tool for IoT based circuit design, and in second he will be talking about PCB design tools. So Dr. Gaurav Kumar is a renowned resource person and having knowledge in various fields. He is basically founder, director and promoter of Magma Research and Consultancy Services, Ambala, Haryana. He possesses more than 24 years of experience in teaching, industry and research. His areas of session delivery in various institutions include open source libraries, AI, web technologies, data science, Python, blockchain, e-tools and LMS for academia, cybersecurity, digital forensic tools, software testing, quantum computing, and related technologies. He delivers the practical hands-on session on recent technologies in workshops, faculty development programs, STCs and webinars, and technical events as resource person in various states of India. And he is associated as jury in various national level technical events also. So with this brief introduction, now I hand over the platform to Dr. Gaurav to start today's sessions, please.
Thank you, sir. Good morning to all the participants. We are starting today's session. I am sharing my presentation. First of all, I am taking it. Kindly wait. I am sharing the presentation. The screen will be shared and then we will start the demonstration part. We will discuss about different tools and technologies for circuit designing. In very first session, we will discuss about implementation of IoT, fog and edge scenarios using open source platform, that is Node.js. ये ऑलरेडी लगी है उधर आ नहीं रहा है किस पे आएगा चेक करने को. Dear participants, I have shared my screen. Kindly confirm, is it audible and visible to all of you? Whether screen is visible and you are getting audio clearly.
Yes, sir.
In chat window or by audio mode, you can communicate whether screen is visible and you are getting.
Yes, sir, visible and audible.
Yes, sir.
Okay. So, dear participants, in this session, we will see how to make use of different platforms, different protocols for IoT with implementation of free and open source toolkit, that is Node-RED. As far as IoT is concerned, Internet of Things is concerned, it is interdisciplinary domain. It is used in computer science, IT, electronics, okay, electrical engineering. You might have seen nowadays we are in the era of multidisciplinary segment in which multiple domain-based researchers are working on some specific scenarios. Okay, so we will see which platforms are available. So screen is visible to all of you. Kindly confirm. In chat window there is a message that screen is not visible. Kindly confirm whether screen is visible or not. Okay. Okay. So for example, as all of you are academicians, you are working, you might be working on different research projects. Many times we have to work on very high performance applications related to IoT. Nowadays we are having so many gadgets. You might have seen that we are using smartphones, IoT based gadgets, smart watches, wearable devices, Amazon Alexa. So on such type of projects, if we want to work locally, for example, I want to work on this type of implementation for my research work. Okay, if we want to work with some implementations related to smart home automation or smart office automation, then how to work on that particular scenario. So we will see. First, before covering any practical demonstration, we will discuss about different concepts. Okay, most of the coverage in this session will be in demonstration mode, will be in practical demonstration mode. Before covering any particular point, the scenario in live demonstration mode, we will discuss about different concepts.
Everyone is requested to please mute their mics.
Okay, so whether you are working on embedded wireless communication or you are working on 4G, 5G or 6G communication, how to make use of high performance implementations, how to integrate IoT with edge computing and cloud computing. Okay, if you are doing research in this particular domain, many times we are stuck at the implementation part. For example, I want to work with energy optimization, power optimization. We want to work with bandwidth optimization in smart home automation. Then which protocols are available and which software we can use. So we will discuss about that particular part. For example, you are working on a research project related to military operations, swarm drones. Okay, you might have seen that nowadays so many sensors available, different platforms available from where we can purchase sensors. If we want to work on a research project on swarm drones, this type of research project, okay, then which particular protocol and which frameworks we have to use. For example, I want to work with smart agriculture based application, okay, agribots. I want to create a dashboard, and in that particular dashboard we want to control each and everything in some particular farming area. For example, we have placed some sensors in agriculture land in farming area, and those sensors are getting data, they are getting signals from its sensors. Okay, but remotely I want to create a dashboard. So which software we have to use, which particular platform we have to use without moving to that location. In same way, for example, you are far away from your home or from your office and you want to see each and everything, you want to visualize each and every device inside your home or office. So that will come under smart home automation or smart office automation. Okay, I want to create a dashboard to see whether all appliances in my home are working properly or not, only with my mobile phone. Then which software we have to use? Okay, whether you are working on this application or you are working for law enforcement. So with these platforms, whatever we will cover in this
Sir, voice is not working properly. It is breaking too much.
just
There
a
may be
minute.
some network issue, sir, but my network is very good.
Okay, just a minute.
Chitranjan sir, audio is fine from our side. We are able to listen on other computer systems also. Please check your connections, please.
Okay. Thank you.
Yes.
Other participants can confirm whether audio and screen is clear. Okay, fine. So, dear participants, whether you are working for some military operations, some military project, you are working on some law enforcement project, or this type of research project, for example, to law enforcement agencies, you want to propose something. Okay. Intelligent applications for agriculture. For example, I want to create a dashboard in my mobile phone, or I want to create a web-based dashboard. So I will show you how to create a web-based dashboard in minimum programming or in zero programming. Okay, you might be thinking that we will be going for some scripting part, we will be going for some programming part. In minimum lines of code or in zero coding, we will be able to create a dashboard with free and open source platforms, whether you are working for smart agriculture applications or you are working for smart home automation, smart office automation. Okay. Industrial automation, we want to control each and everything in one particular industrial establishment. For example, some manufacturing plant, some particular assembly line, okay, industrial assembly line, some particular workshop, and inside that particular place, whatever appliances, whatever gadgets we have deployed, we want to control remotely, we want to view remotely, okay, or smart ambulance. All of these topics, all of these domains are closely associated with IoT as well as wireless networks. Okay, Internet of Things as well as wireless networks as well as sensor technology. If you are working on 5G or 6G based research domain, in that case also you can use, for example, we want to propose a smart ambulance. In that particular ambulance, we have placed some sensors. Those sensors are sensing data from human body, from patient, and we want to send that particular data remotely to a doctor, remotely to medical expert, or to multi-specialty lab. So first of all, we should be clear about this particular concept. If I want to work with any of these research projects, whether it is 5G powered medical robots, smart ambulance, industrial automation, intelligent applications for agriculture, which platforms are available, which software we have to use. As far as software implementations are concerned related to IoT and cloud, two things we need, two major things. And for both of these segments, we will use free and open source software. Two things. In very first point, we need a particular protocol. First of all, we should understand in IoT which type of protocol is used for communication. In IoT, we have to use very high performance protocol that is known as MQTT protocol, that is available in free distribution, message queuing telemetry transport, mosquito.org. Thousands of software available. Okay, I will show you its demonstration also. This is mosquito.org. It is freely available from Eclipse Foundation. Everybody knows that Eclipse is very, very prominent in delivering free and open source software. Okay, its IDEs are available, so many other software available. So if I want to work with IoT scenario, I want to interconnect, I want to interface multiple sensors In that case, we have to use a specialized software that is known as IoT broker. Okay, so this is IoT broker, not only Mosquitto, HiveMQ, this one for industrial automation. Okay, it might be looking somewhat difficult or complex, but when I will show you its demonstration, you will see it is very easy. It is as easy as Paintbrush or MS Word. Simply drag and drop. No need to write even a single line of code. If you want to work with smart home automation, for example, I want to connect all of my appliances in home with my mobile phone. It can be done. Washing machine, microwave oven, car, GPS. I want to connect LED refrigerator, and one interface, one dashboard I want to create in my mobile phone with Android app. That is possible. But first of all, we should be clear that which particular protocol we have to use. Protocol means communication protocol, communication interface. In case of IoT, we have to work with very specialized software, very specialized applications that is known as MQTT. Okay, and lots of other software available. You can see that FlowHub is available, and all of these are completely free and open source. FlowHub, NoFlow.js, Praxis Live. Praxis Live, and so you can see that in this way. If I want to create a scenario in this particular format, okay, no need to write programs, no need to write scripts. Generally, when we work with Arduino or Raspberry Pi, you might have seen that we have to write some scripts. After that, we have to burn it. Okay, then that particular sensor interface, after that we will be able to get some data. But if we are using these platforms, Praxis Live, or we are using HiveMQ, or we are using Node.js or NoFlow.js, okay, these are completely free and open source. So if I want to create this type of scenario, okay, for example, some particular scenario we want to create for our application, some particular dashboard we want to create, so it can be done. Lots of examples given here. So you can see that in this way. For example, multiple sensors we have placed, and we want to work on a particular implementation on laptop, okay, on laptop or on mobile phone. So with these platforms, we can work with emulation. Okay, there are two terms. One is known as simulation, second is emulation. In case of simulation, what we do? You might have seen that in case of simulation, we work entirely in virtual mode. Everything is in drag and drop mode, whether you are using some particular simulator, for example, NS2 or MATLAB. Okay, so we are having graphical user interface, and with that graphical user interface, we are able to create some virtual scenario. But if I want to attach actual sensors, okay, so I want to create a dashboard, but with that dashboard, some part is actual sensor, some part is virtual scenario. So mixture of that. Okay, that is known as a test bed. You might have heard about this term. That is known as a test bed or emulation. Test bed means some particular scenarios are actually present. For example, for my agriculture domain, I want to place some sensors in farming area. Okay, sensors are actual, farming area is actual. Okay, farming area is not virtual. Agriculture land is actual, my crops are actual. Okay, but dashboard is virtual. This is known as test bed. And if you are going on some particular patent, you want to apply for some patents, you want to go for intellectual property rights, you want to go for very good publication, in that case, generally we have to go for test beds or emulation based implementation. In only simulation, many times work is not accepted. We have to show that we have actually placed some sensors. We have actually used some agriculture area. We have actually used some longitude, latitude. Okay, so these platforms gives us that particular scenario. Either you can use HiveMQ or you will be able to use Mosquito. Okay, so these links I have given in this presentation. At end of this session, I will share this PPT to all of you so that you will be able to work on it. So lots of other software available. This one. Okay, so now we will see by which way we can work. So one scenario to work with IoT application is protocol, that is MQTT, okay, HiveMQ or any other you can use. Now using which platform we will be able to work on the dashboard. Now major part will start. Now major implementation will start, working with dashboard. To work with dashboard, we have a very powerful library that I am covering today in demonstration, that is known as Node-RED. Very easy to use. Anybody who knows how to operate a computer, how to work on MS Office, they will be able to work on this software. Node-RED software, very easy to use. And you can see that this is known as low code programming platform, low code programming for event driven applications. If you want to collect real-time data from agriculture land, if you want to collect real-time data from GPS, from Google Earth, from Google Map, if you want to collect real-time data from human body via sensors, using Node-RED we will be able to do. So what is Node-RED? Node-RED is a free and open source software on which we can create a GUI dashboard. In that particular GUI dashboard, I will be able to view everything. Even if I want to control my Wi-Fi, nearby Wi-Fi system, that can also be done. If you want to control nearby gadgets, that can also be created. So drag and drop mode, we will be able to create a scenario with Node-RED. So yes, I will show you this particular demonstration. After that, you will be able to work on it. At end of this session, I will share this PPT to all of you. Now, by which way we can work on Node-RED? See this very carefully. Node-RED is a plugin. Node-RED is a module that is installed onto Node.js. Onto Node.js it is installed. So if there are multiple ways to work with Node-RED, one way I want to install it on my laptop, on my system. Okay, if I want to install Node-RED in my laptop, in that case, what I will do, first of all, I will download and install Node.js. Okay, first of all, I will download and install Node.js. This is JavaScript based library, but no need to worry. Each and everything is in GUI mode. Okay, so first of all, we have to download this software, Node.js, and onto Node.js, we have to install Node-RED. Okay, in few minutes, it will be ready. This is one way, this one, run locally. If you want to execute it on Docker or on standalone system. If you want to install it on Raspberry Pi, for example, we are working on some research project and I want to install it on Raspberry Pi or Arduino or Android or BeagleBone Black, it can be done. If I want to work on cloud, Microsoft Azure, Flowfuse, Amazon Web Service, anywhere. So full flexibility is there. Now, I will show you its cloud variant. Okay, so but before that we will see which features are available. So you can see that it can be executed on low cost hardware including Raspberry Pi as well as on the cloud. Okay, any type of device. Thousands of plugins available. Where these plugins are available? These plugins are available on npm.js. This one is the website npmjs.com. If I want to install some additional packages, for example, I want to work with OpenStreetMap. Okay, OpenStreetMap. I want to install OpenStreetMap with my Node.js, Node-RED. So you can see it is available. If I want to work with Arduino, I want to link my Arduino board. This is also available. So you can see Node-RED, Arduino. So virtually I will be able to work with Arduino board. Okay. For example, we are using one Arduino board, some sensors are placed, but that Arduino board I want to control with my mobile phone. But how it is possible? I'm repeating this point. I am having one actual Arduino board, actual sensors. It is placed in some agriculture land or in my office or in my home. But major thing is that by which way I will be able to read its values. I want to create a dashboard in my mobile phone. So what I will do, I will use Node-RED. So I will install Node-RED in my laptop. I will install Node-RED in my mobile phone, okay, or its app, and that I will connect with my Arduino board through Wi-Fi or by internet, okay, through Wi-Fi or Bluetooth or whatever communication channel you want to use. With any module you will be able to interconnect. If you want to work with Raspberry Pi, okay, Raspberry Pi, that is also available. Yes. So you can see in same way, for example, I want to work with Wi-Fi. I want to scan Wi-Fi. So you can see that Node Wi-Fi module, Node.js Wi-Fi. So thousands of plugins available, which we can control with our Node-RED platform. Now we will see how to work on that. There are multiple ways to work with this particular Node-RED. If you want to work on cloud, then FlowFuse, okay, its trial version is available. Otherwise, you can use Replit. Okay, so we will see. And so many plugins available. For every application, its plugins are available. Okay, I'm logging in with my account. I will show you its demonstration. So this one is the interface, and you can see that this one, Node-RED. Okay. So on cloud, I am showing you this one. So you will see that it is as easy as working on any web-based application. Okay, very simple to work with. You can download or install Node.js. If you want to work with local system, it can be done. Okay, download Node.js and it will be executable. Node.js. So you can see that this one is the interface. Is this visible to all of you? This is Node-RED platform. Is this screen visible to all participants?
Yes, sir, visible.
Okay, so you can see that this one. This is Node-RED editor. This is known as Node-RED platform. We are executing it on cloud. Now we will see how to work on some scenarios. So you can see at left hand side, this is complete palette. When you will download and install Node.js, Node-RED, this interface will be visible. Some icons are already available. Some icons, some plugins, these are already available. This is my working panel. In between, at the central level, you can see that this is my working panel. Here we create this scenario. Now I will show you some scenarios by which way we can work. Simply inject, drag and drop. Double click. Initiate communication. Done. This one to create the output screen, okay, output messages, okay, or output signals. Now I want to connect. So this particular thing can be your refrigerator, it can be your home appliance or anything else. So first of all, I'm showing you very basic scenario. After that, I will show you how to link Wi-Fi system, how to link other scenarios. Okay. Simply, if I want to link, drag and drop. So you can see, simply I have connected this. Up to now, I have not written even a single line of code. Okay, simply by drag and drop. I want to run it. Deploy at top right, deploy. Now run. You can see that this particular message we are receiving. This particular message. Okay, in this way. Now we will see if we want to work with IoT system, IoT scenario, that is the major focus, so that you will be able to understand. Now onwards, see this very carefully what we are doing.
Excuse me, sir.
Yes, ma'am, please.
Sir, can you explain again how did we get this platform on which we are working?
Yes, ma'am. Yes, ma'am. I'm showing. To work with Node.js, so I'm showing it in Notepad. Okay, I'm explaining this particular part in Notepad. And at end of this session, I will share this Notepad file to all of you so that you will be able to work on it. And working with Node-RED. Is this Notepad visible to all of you? Kindly confirm. Is this Notepad visible?
Yes, sir.
Yes.
Okay, now see this very carefully. What we will do? There are multiple ways. Local installation. In case of local installation, what we will do? This is very first part, local installation. In local installation, download and install Node.js. Okay, from nodejs.org. After that, this one, in nodejs.org, in Node.js directory, install Node-RED. Okay, with npm.js, with npm command. So now you will see, now you might be thinking, what is the npm command? So this is the website npm.js. So if I want to install Node-RED, so I will write here Node-RED and yes, from npm.js we will download that particular software. This is npm. Okay, and any software can be installed with npm-i. Okay, npm-i Node-RED. For example, this is my command prompt. So I'm opening my command prompt. For example, this is my command prompt. So what I will write here, npm-i Node-RED. If my internet is working, in that case, it will be installed automatically. And after that, we will be able to execute. This is local installation. Okay. In Node-RED. Second is cloud installation. That is the easiest way on which I am working. Okay. Currently, in this session, I am working on cloud installation. Cloud installation, in that Replit. Okay. Sign up on replit.com. Replit.com and install Node-RED. In replit.com, you will get the option to install Node-RED. Okay, in single click, you will be able to install. For example, here, this is my Replit account. This is a cloud. So apps, view all, create. So you can see that what I will do, create. On click of create, I will write here, install Node-RED. Simply write here, install Node-RED. Start building. It is a cloud-based platform with AI. This is artificial intelligence-based platform. Okay, no need to install by any command. As soon as I will click start building, so many commands will be executed automatically. So similar to ChatGPT. So what is difference between ChatGPT and Replit? In case of ChatGPT, that particular platform gives us the command. Those commands we have to execute manually one by one. But if same thing I am doing in Replit, nothing to do. Simply write here install Node-RED. It will give all commands and all modules will be installed automatically. Okay, and then you will get this type of interface. Okay, so you will be able to work on this. So you can see that in same way I have written. So if I want to install scan Wi-Fi, if I want to install open weather map, I will write in its AI assistant. It is AI based platform. So I will write here install that particular platform. That particular will be ready, and I will be provided. I will be given its online URL. This is online URL. Okay, so this one. We are running now. Okay, is this visible to all of you? Is this clear to all participants? So either you will be able to work locally, or better it is work on cloud, on Replit cloud. Okay, I will share this presentation to all of you at end of the session. Okay, at end of this session I will share this presentation so that you will be able to work, because in this PPT everything is given. If you want to link WhatsApp, that is also possible. For example, I want to link my WhatsApp account, so that is also possible. So you can see that simply WhatsApp. I want to get notifications on my WhatsApp messages. So you can see this one, WhatsApp business platform, NPM I WhatsApp. For whatever signals are transmitting by Arduino, whatever communication is going through Arduino or Raspberry Pi, I want to get all messages in my WhatsApp, or in my WeChat, or in my Telegram, or in my message. Everything is possible. So simply I will have to execute this command npm I WhatsApp. It will be done. Okay. Now we will see how to work on cloud-based MQTT scenario. How to work on MQTT-based implementation. See this very carefully. I am deleting this part. This is MQTT. MQTT in, MQTT out. Okay. HTTP, from where we want to get responses, and scan Wi-Fi. So you can see scan Wi-Fi scanner. Sir? Yes, ma'am.
Can you show your notepad screen, please?
Yes, ma'am. This one. So I'm sending it in a chat window also. Okay, in chat I'm pasting this particular message so that you will be able to use it. Okay, in chat message I have written it. Is this visible to all of you? Wi-Fi scanner. So you can see this we are attaching, this we have linked. So you can see that I am not writing any code. I am not writing any script. Connect Wi-Fi scanner. Okay, Wi-Fi scanner with signal strength. Done. Okay, output. Done. So deploy, run. So you can see that currently we are working on that particular scenario. We are working on direct leased line. Okay, if I'm working on some particular Wi-Fi connection, in that case it will be able to access. Okay, currently we are directly linked with a leased line with direct internet connection. If I'm working with some particular Wi-Fi hotspot, in that case it will show. Currently it is showing no scanning utility found. Why it is showing no scanning utility? Because in this system, in this lab of computer on which I am working, I am not using any Wi-Fi connection. Okay, if you are using some Wi-Fi connection, in that case it will give that particular signal strength. Now we will see by which way we can work on IoT scenario. So this is MQTT in, MQTT out, MQTT out. Okay, this one. Connect to broker. Now, which message we want to send? Which type of message we want to send? This one, connect. Now, what is this MQTT? This is same IoT protocol. For example, this one is first MQTT. This is my AC, done. This is my car GPS. Okay, two devices we are taking. Okay, this one. Now it is asking me to connect to our remote server, to connect to our remote scenario. Plus, add MQTT broker config node. Here, what we will do, we will specify the parameters related to our IoT. For testing, we can use Mosquito or we can use MQTT cool test client. Okay, test client. MQTT.cool and this one. Lots of clients available. You can directly search on internet. This one. Connect. This is my test client. This is IoT broker client. Now whatever message I will send from here. For example, I want to send some message from this dashboard. Okay. For example, start communication. We want to send it to this particular device. We want to send to this particular device. So what we will do? First of all, we have to connect. In case of IoT, first of all, we should be clear about the terminology. It is asking for the subscriptions. Subscription means acceptance. In case of web-based architecture, in case of cloud-based platforms, we use client-server architecture. In web-based computing, you might have seen we use client-server architecture. Client-server request response. In case of IoT, we do not use the term client-server or request response. In case of IoT, we use the terms publish and subscribe. Publish means we are sending data. Subscribe means we are receiving data. If we want to send data to some sensor, in that case, we are publishing it. If I want to receive data, in that case, we will use subscription. So to subscription account, I am creating car GPS. And this one is your AC. Okay, two messages we have subscribed. Two topics. And this one is your Mosquito. Okay, so what I will do, plus this one, IoT broker. What is broker? What is meaning of broker? In case of client server architecture, we use the term server. In web-based computing, in web-based applications, we use the term server. In case of IoT, there is no term server. In IoT, we do not use the term server. We use the term broker. Okay. So, for example, we are having one Arduino board or Raspberry Pi. We will not say that it is a particular server. We will say that it is a broker, IoT broker, that will take care of all communications. Okay. So, this one, add. What is topic? This. Second, this particular IoT broker or and device. This one. So from where we have taken it? From test.mosquito.org. Add. Done. Deploy. Now you can see it is showing connected. Now I'm sending data. It is received here. So you can see one message received in AC, one message received in car GPS. I'm again clicking here. So it is only for demonstration. So you can see that these messages we are receiving here. For example, one more message, one more we are taking here. Anything we can take. Device 2. Test.mosquito.org. We will create another, we will take another MQTT. So you can see in MQTT out, what is the server? Broker MQTT. This one, device 2. So which protocol we are using, MQTT 3 or MQTT 5? Add which topic? Device 2. Done. Connect it. Okay, no need of any coding, no need of any scripting, simply drag and drop. Okay, so what we can do here, in this particular, in place of this icon, what we can do, we can have some Arduino board, we can have some sensor, we can have Raspberry Pi or anything else. So connected. Now run. So you can see that these messages we are receiving here. This is test client. In same way, for example, some other part, some other segment we want to communicate. Okay, so for example, some random message we want to send. So I'm deleting this particular part. This connection we are deleting to device 2. This one is range. Range icon we have dragged, double click. We want to send some random value, some random data. Okay, it is only for demonstration. Done. Connect. Now this one. Okay, and deploy. Connected. Run. Now you will see that this 2 is received here. Now if I will again click, if I click again, then some other message will be received. Actually, what we are doing currently, we are working on a single system without any actual sensors. But if we are using some actual sensors, in that case, what we will do? So this setting, same settings, this test.mosquito.org 1883, these value we will put in settings of AC. In settings of AC, in settings of our car GPS, we will put same credentials. These credentials we will put. So by this way, what will happen? AC is connected to Mosquito. Mosquito is connected to Node-RED. Node-RED is in our control. Okay, it means with Node-RED. So this is web-based scenario. If I want to work with, for example, my mobile phone, in that case, what we will do? Play.google.com. I'm going to Google Play Store, apps. I will take one app, okay, IoT Broker, or simply search for MQTT in Google Play Store. So you can see that control the things by IoT dashboard, MQTT dash. So in this way. So you can see. So simply what we will do, we will download and install, we will install this app in my mobile phone. Same apps are available for iPhone also, for BlackBerry, for Windows, for every platform, these apps are available. What we will do, we will simply download hundreds of apps available for MQTT. So you can see that in this way. If you want to create a dashboard to control home appliances, but what we need, this when we will download and install this app, it will ask for the credentials. It will ask for the username, password, URL. So what we will put? We will put this particular credential. These credentials we will put in Google Play Store app. Same credentials are put in AC, car, GPS, or in our end devices. So by which way these are connected? Mobile, with our mobile phone, we will be having a dashboard. We will be having push buttons. Okay, in this particular app, in these apps, you will be having some buttons, some links. So as soon as you will press on, off, okay, or temperature this one, temperature that one, this message will move to MQTT broker. It is connected to satellite. It is connected to internet. Otherwise, you might have seen, for example, I want to switch on or off my LED, my LED TV. I want to switch on or off my LED TV from 1000 kilometers away. Is it possible? It is not possible. Even if I'm having remote, even it is not possible beyond 100 meters, because that particular range is very limited, 20 meter, 50 meter or 100 meters. If I want to control my LED TV from any other city, if I want to control my TV from my mobile phone, in that case, my dashboard as well as TV, both should be connected to internet. So what we will do, in settings of my TV, I will put these values. I will connect my TV, I will connect my... Yes, actually this is a cloud IoT. This is a cloud IoT broker. One IoT, so see this very carefully. If I am downloading and installing this particular software, so there are two ways to work with IoT broker. If I am downloading and installing Mosquito in my Arduino or in my laptop, in that case it is local installation. I will be able to work on only smart home automation, only smart office automation, nearby devices. Okay, whatever devices are in that particular range. But I want to control from any other city. In that case, this Mosquito should be available on internet. So this is internet variant of Mosquito. This is cloud variant of Mosquito. If I want to work with very secured platform, for example, in a range near to our home, around 20-30 kilometers range or around 5 to 10 kilometers range, our agriculture area exists. In that case, we can download Mosquito in our laptop. We can download Mosquito in our Arduino board, and we can work. That is local installation. Okay, that is local connectivity. But I want to see each and everything from 1000 kilometers away while traveling. In that case, my Mosquito should be available on internet. Are you getting what I mean to say? My Mosquito or that software, that IoT broker should be available on internet. This is internet variant. It is available on internet. So what we will do, all devices we will connect in this way. Okay, so device to AC, car GPS or washing machine, and there is no limit. There is no limit. Any number of devices, thousands of devices, you will be able to control. If you want to enable or disable some particular point, some specific device, depending upon particular condition, so that can also be done. Okay, you can put some function, range or delay. If you want to put some delay, if you want to add some additional parameters, if you want to add some additional plugins, that can also be done.
So if we have some agriculture sensors,
yes,
that is wirelessly means enabled. So how can we interface, because that are the hardware equipments? Okay,
actually, if we are having sensors, obviously these sensors will be integrated in Arduino or Raspberry Pi. It means some motherboard will be used. In that particular motherboard, you will put that particular setting. As soon as in Arduino or Raspberry Pi, you will put this setting, that will be connected to internet. That will be connected to a cloud IoT broker. And same settings we have put in our mobile phone app. So by this way, multi-dimensional or multi-level connectivity is available. Your mobile phone is having this platform. Okay, your Arduino is connected to this particular URL and this particular IP address, URL and port number. And with your mobile phone, you will be able to connect. Okay, so you can try this part also. as this one is an online session, so this demonstration can also be done, but in that case my mobile phone should be connected to that. Okay, so what we can do, as soon as you will install it, you will be having interface. It will ask you to enter username, password, this particular URL and port number. We can enter it, and after that you can connect multiple devices. You can link multiple devices, your GPS, your LED, or your sensors, humidity sensor, temperature sensor, whatever it is, you will be able to
take some printout from my mobile in the printer that is Wi-Fi enabled.
Yes.
Is it possible?
Yeah, that is also possible. So if you want to connect your printer, so nowadays Wi-Fi printers are available.
Yes,
If you want to connect your printer to IoT, so in printer settings you have to put this particular credential. In that case your printer will be connected to IoT broker, and in my mobile phone app I will be able to put credentials or settings associated with printer. So printer is connected to IoT broker, and IoT broker is controllable with my mobile app. So in that case, multi-level connectivity will be available. And lots of other platforms available, not only this one. So one more platform I'm showing you. My devices. If you want to work on some particular app, my devices dashboard. Okay, so you can use this. Simply you can create account on my devices and you will be able to work on it. Virtual sensors. Its free variants are available. If you want to use virtual sensors, if you want to use virtual devices, so all of these devices, for example, I want in my implementation, I want to use this type of sensor. So obviously its cost is, so you can see, around $400. Without spending $400, I want to use it for my research. Without spending this one amount, I want to use it in my research. So simply in mydevices.com you can create account. Okay, it will give you virtual scenario of these sensors. Okay, in drag and drop mode. Even you will be able to link these sensors with this one. Okay, if you want to add something, for example, you want to add some additional devices. Open street map, okay, or open weather map, this one. So npm install or npm I open weather map. From any remote location you will be able to capture longitude, latitude, okay, so that you can perform. So description, pressure, humidity, speed. If I need virtual Raspberry Pi, SenseHat simulator Pi. I need virtual Raspberry Pi. SenseHat Raspberry Pi. So this one you will be able to link. So virtually, if in my Node-RED platform I want to use virtual Raspberry Pi, I want to use virtual Arduino. Actually many things in demonstration, in implementations need physical installation, needs physical sensors. Okay, so as this one is an online session, it is an ICT based session, hybrid mode. So to some extent I can show you the demonstration, and for some implementations we need actual sensors, so that some physical installation, some physical things can be demonstrated. Okay, but I'm trying to cover, I'm trying to tell the process by which way you can work locally on your IoT based implementations. Okay, in same way, for example, I want to capture something from a web-based scenario, okay, from web server debug. So from which URL? Okay, HTTP request inject this one. Any website, for example, we want to capture some data from a particular website. Done, deploy, and you will see. So this one. So you can see that this one. In real time, we want to fetch data. In real time, we want to capture data from some web-based application, from some web-based URL. Okay, any website can be put. For example, you have stored your data in some live URL, and from that live URL, you want to capture the data using HTTP request. You will be able to send. Same HTTP request you want to send to MQTT. Now you can see MQTT. Same output you want to send to MQTT. Now this one, IoT broker, and this one, this copy, and I'm placing it here. Add car GPS, done, deploy, and run. Now you can see that particular data will be received. Okay, successfully injected, and it will be received, okay, on this particular panel. It is showing connected. Update this one, or deploy, run, and you will be able to get that particular message. Okay, so multi-level connectivity, payload, enable. So enable or disable different settings we will be able to do. If we want to send data, if we want to receive data from some sensor, in that case we will use MQTT in. Okay, MQTT in. So whatever data we are sensing, and we can link with the output. From where we want to send data? In same way, deploy, done. Now you can see this one, and here we are receiving this particular signal. Okay, whatever signals we are transmitting, these will be received. So you can see without any coding, without any scripting, we will be able to work. If I want to store this particular data, whatever data we are streaming, whatever signals we are streaming, we want to store in CSV file or in HTML file, we can work on that. So you can see write file, whatever data we are getting from sensors. Connect, double click, where we want to send. So here we can put path in C drive, D drive, or whatever, or cloud link. This particular data will be stored. Okay, so Node-RED you can explore, easy to use, and simply in Node-RED, in Replit you can simply write install Node.js and then Node-RED.
Search and command.
Yes. In AI Assistant, it is giving you the complete interface.
Install.
Okay, if you want to work with any other broker, that is also possible. So Cloud MQTT, that is also possible. okay, Cloud MQTT or Hive MQ Cloud. Okay, any of these you can take.
इसमें क्या command डालनी है?
So you can see.
Node.js.
Yes. Yes, yes. Okay, so you can explore this platform. New schematic, which component we want to add. Any of these we can take. This one. Simply we have added it. One more we are taking. Okay, how many registers we want to take? We want to take 3 registers. So you can see this one. Now I want to rotate it. Okay, we want to rotate R by pressing R key from keyboard. Is it visible to all of you? Kindly confirm. Is this process visible to all?
Yes, sir, visible.
Okay, so you can see that we are able to work on it. So 3 registers we have taken. So this same circuit I am creating, I will share this PPT to all of you so that you will be able to work. Now I need 3 LEDs. I want to take 3 multiple LEDs. So from this particular palette, so you can see that Arduino board is also available. This one, LED 5mm red. Okay, this one red we have taken. One green and one blue. Okay, it is only for demonstration. 3 LEDs we are taking, simply dragged. Okay, now accordingly we will change it. R. Okay, so click R so that I will be able to rotate it. Now it is rotated by R key from keyboard. Are you able to understand this process? Is it looking easy or difficult? Kindly confirm whether it is looking difficult. Simply drag and drop, and by R we are able to place. Now we will connect. So you can see this is wiring tool, wire. So this is wire, this is wiring tool. This is wire.
Sir, how to rotate these components?
By R key from your keyboard. Simply press R, or you will be able to rotate from this one. Okay, so this one by clicking, for example, I want to rotate this one. Click and format. So you can see that this one rotate left, rotate right. Either by menu or by clicking on R, you will be able to rotate.
Okay. Sir, how to change the color of the LED?
Yes, just a minute, I am telling you. Okay, so first of all I'm creating this connection, and then I will show how to change color of the LEDs. So you can see that this is LED diodes. In diodes, so this is the button. Okay, at bottom right, click. So blue, so 3mm LED, 5mm LED. Is this visible? R for green, R for red, G for green, B for blue. Is it clear, ma'am? So click.
Yeah.
Sir,
For example, I need this.
hello.
I need.
Excuse me,
Yes,
sir.
yes.
Sir,
Yes,
can
sir,
you
please.
please zoom a little bit because we are not able to see what you are writing
Okay.
there.
Just a minute. Is it okay now?
Yes, sir. Yes, sir.
Okay, so now you can see that this one is created. So we have created 3 registers. If I need more registers, for example, I need a register of this particular variant, RXL 0.5 US. These are different variants. Okay, I need this particular register. So with every component, its different variants are available. So you can see that what is the radius. So this is the capacitor, and RAD, this one is the capacitor, and what is this parameter. Now this is ready. Now we need one power supply. Okay, we need power supply. This one, simply click, drop, drag and drop. simply we have placed it here. Now you can see first, now we will create the connections. Okay, so we will create this particular connection wire. This is our wiring. Simply you can see, click, this connection to this one. Okay, this one connection is ready from power supply to registers, and now we will connect these three. We are connecting this one. Now up to now, for in between I will show you up to now what is the 3D view. Okay, this one and this to this one. Okay, now we need one ground. So up to now I want to see its PCB. Okay, only this part. Only up to this part you can see that BOM file. This is convert schematic to PCB. Convert schematic to PCB. Click. Same option is available in KiCad. Okay, keep going. Same option is available in KiCad. PCB is getting ready, and up to this point. After that, I will add a ground, and then we will see how to work on that. Convert schematic, and now I have, first of all, I have to save it. So this is my, okay, LEDs. So we have to give some name, LEDs, and now saved. Now this is how many units. So you can see that in which unit copper layer, how many copper layers I need in this PCB. Okay, to board outline, circular, rectangular, or this one. Okay, what is dimension? Apply. So this is my PCB. So this is my board. This is my PCB board. I want to place where I want to place. So this is LED. This is LED. We are placing it here. This is my register. This one is second register. This is third register. Okay. This PCB is ready. So now I want to see its 3D view. This is 3D view of my PCB. Okay, so we can check it. So you can verify whether it is correct or not. If I want to see its 2D view, this is 2D view. Okay, this one is 2-dimensional view. If I want to create its Gerber file, so you can see that this is PCB fabrication file, Gerber file. Okay, so we can save it. So first of all, we will complete this circuit. Okay, don't save. Now we have to add one ground. Okay, one ground we are adding, one connection we are adding. So this one is ground. We are placing here and save. So you can see with wirings, with same wiring, we will connect. Click, and with this ground. This is ready, and one connection we will give to this one. Power supply to this. Now is this circuit complete? Now this circuit is complete. Save. Convert schematic to PCB. Keep going. Copper layers. Apply. Or I want to take a circular. Okay, this is my circular PCB. Now in this circular PCB, this one, these components I want to place. Where I want to place. So you can see that this one, I want to place all registers in one way. So in VLSI programming, in PCB, you might have seen there is another research area that is known as floor planning. I think you might be aware with this term, VLSI floor planning. Floor planning means whatever area we are having, how to optimize it. Rather than taking so very large board, and on that particular large board, we are creating that thing. Okay. This is 2D view. Okay, and now we want to see its 3D view. This is 3D view. Okay, we can change its properties. Okay, so you can see that this one, units, border color. So which color we want to set, and 3D models, this one. So you can see in this way. So distance layer, it's very, very large. Okay, and what is the background? In 2D view, this is our 2D view. Okay, convert. This is BOM file. So you can see this is BOM file. One click of this BOM file. Now you can see that this particular BOM file, in this BOM file, we can check whether manufacturing plant, whether manufacturing unit is having that component or not. So these are the components. So LED, these two LEDs are with this particular company. Okay, but this particular register, it is not available. But so we want to see it. So assign LCSC part. We will assign this register to the availability, to the available component in that company. So assign LCSC part. So which LCSC? So any of these we can take. So for example, registers. So obviously we are going for registers. So in registers, this one, through hole registers, and which of these registers we can take, and we can go for its comparison also, whether what is the cost of that particular register. So any of these we can take. So you can see that this one, for example, this we are taking, it is only for demonstration. So its cost is $0.013. So you can see that whatever register we are taking, so this is view, this one is view of that register, and its cost is $0.01. Assign. One click order part. Okay. Bill of material. So you can see that it is redirecting me to that particular website LCSC, and we will be able to order it. Okay, in how much amount we will be able to order this particular PCB. So if I move ahead, in that case it will show me the price. Okay, if I want to create its LCSC, it's a Gerber file. So you can see that this one, backup project, recovery, and so first of all, I'm saving it, keep it, and this one, PCB, keep going, apply copper layer, radius, and DRC, check DRC. Okay, design. So as in PPT also we have mentioned what is DRC, ERC check. So design rule check. Okay, so we can integrate it. This one is LED, this one. So we can go for this floor planning, DRC. Now it is fine, no issue. And this is Gerber file, PCB fabrication Gerber file. Keep going, generate Gerber.
Layout.
This is, you can see that, this one. So just randomly we have created it. It's generate Gerber file, one click order PCB.
The layout, it has itself given the layout.
Yes, it has, so we have selected circular layout. We can select rectangle also.
Circuits, the PCB layout means the tracks that will be made on the PC.
Yes, that it has taken automatically.
Can we see that?
Okay, just a minute. Okay. So generate Gerber, one click order PCB SMT. Okay. So we will be redirected to that platform. So you can see that it will estimate the cost. What is cost associated with this implementation. So in $2, you can see that in only $2, whatever design we have created.
How many PCBs? One PCB only.
Okay, so you can see that this one.
3 days lead time. $2 per PCB or PCB quantity?
Yes.
30 point estimate for piece. 5 PCBs.
Okay.
5
So you can
PCBs.
see that this one. Now, if you want to customize it or if you want to change this particular scenario, that can be done. Up to now, is it clear to all of you? Kindly confirm. Is this clear to all participants? Up to now, whatever we have discussed.
Yes, sir.
Okay. And how much
Yes,
is it
sir,
looking
clear.
or easy? Is it looking easy? Very easy drag and drop mode we are working. So different PCB tools available. For example, we want to take some pad. So you can see that pad. We want to. So I want to put some message also. So you can see text. For example, I want to put some text here. This is NITTR. So we want to put some watermark. Okay, so this one, it will be printed. So in this way, it will be printed. So as a so on PCB, we want to put some watermark also. In same way, dimensions. So you can see dimensions. At right hand side, its complete details is available. So we want to see its dimension. So you can see that this one. I want to see its radius. So click here and this one. I want to analyze it. How much mm? Are you able to view it?
Yes.
Okay, so grouping, ungrouping. We want to put some image. That is also possible. So in this way, this PCB will be ready in 2D format, in 3D format. It will be ready. Yes, sir, please.
Sir, can you please share again, like how did you convert the schematic into the Gerber file and the PCB layout? How can we see again that?
Okay, sure, sir, sure. So you can see that this is our circuit that we have created. Up
Yes,
to this,
sir.
is
Yes,
this clear?
circuit I have made, sir. Circuit I have made. After that,
Now, see, now you, first of all, you have to save it in file, save, or simply Control S. Okay. Now you can see that this is the symbol. This one is the button. Convert schematic to PCB.
okay.
Is this visible, sir?
Yes, sir. Yes, sir.
Now click. It will ask for some confirmation, and you simply click on keep going. Now, how many copper layers? So 2, 4, whatever it is. Circular board is circular or rectangular or round rectangular or custom. I want some custom board. So that can also be done. Now round rectangular, apply. Now this is my PCB. Okay. In this, we want to place. So first of all, you have to just a minute. We have to place it. Okay, simply drag and drop. So this is our board where we want to place. This is floor planning part we are doing. We are placing these resistors here, this LED here. So 3 LEDs are adjacent to each other. These are near to each other. These resistors are near to each other. You can see that connections will not break. So I want to create a very effective design. Okay, designing part. So this one.
Yes.
This one. Now after that, what we will do? DRC check. Okay, so save it. DRC check. No error. Now what we will do? In 3D, click on 3D. Now you can see that in 3D we will be able to see it from top, from bottom. What will be its look and feel? What will be its interface? At right hand side, its details are available. What is the color of board? Okay, which type of board we have to use? Generally blue board is used. but it depends on your choice. So depending upon your choice, that particular design will be given. Okay, so this is our 2D design. So click on 2D. This is 2D button. 3D. I want to show, I want to view this in 2D. So these are 3 LEDs where I have placed. If I want to view it in 3D, that can be done. Is this clear to all of you? Kindly confirm.
Yes, sir. Yes, sir.
Okay, now one more scenario we will see. One more example we will discuss. One more case study related to PCB designing. File new. So you can see from here also you can go for export BOM. Okay, BOM file or generate PCB fabrication file. Export. Now one more project we will see. New schematic. So first of all I'm deleting previous. Now new schematic or PCB you can take. So as soon as you will click on this one, so this is our blank dashboard, blank working panel. We can save it. For example, I want to save it with Arduino project. Save. We want to simulate, we want to create PCB along with Arduino board. For that, one scenario I have already created. Okay, so you can see that this one. For example, this particular project we want to implement. One Arduino board, Arduino Nano, 10K register, 330 register, push button, red LED. Okay, this is our next assignment. Now, how to create its PCB? First of all, we should be clear about the numbering or that particular ID associated with each device. Arduino Nano means C9900017889. So these are the numbers I have written separately. Okay, if I want to take red LED, either you can take from library. So either you can take from library, but common library, if it is not available in library, then what we will do? For example, I want to use some register Arduino. Arduino is not available here. So you can see I am writing here Arduino. It is not available. I am writing here Raspberry. I am writing here, for example, Wi-Fi. I am writing here Bluetooth. These are not available. So, but I want to use Bluetooth, Wi-Fi, push button. So for that, we will search for the library. Simply give a number of that particular device. That is device ID, enter. This is Arduino Nano. Click, place.
From where did we get this number?
So you can see that Arduino is placed. Is this clear? I'm repeating this point. I'm repeating this process. I know that Arduino Nano number is this one. Library. Search that particular ID. Okay. So as soon as you will search, it will show that this number is associated with Arduino Nano. Click, place. Where I want to place? Here I want to place. If I want to view its file, if I want to view its schema, 3D view. So up to now I want to see it. So you can see that this is, and this one is my Arduino. Okay, Arduino Nano.
This is the footprint name that you have taken, sir? Or what is
this is ID we have taken. Okay.
This ID we can get from Google Library.
Okay, so this one. Now, so you can see that this one. Simply search Arduino Nano and place. Now where I want to place? I want to place it here. Now one Arduino Nano I have taken. After that, what I will do? I need some other components. So all components I am taking. This one. Red LED. Okay, so this particular design I want to create. This particular PCB I want to create. So its numbers should be clear. See this one. It is associated with this LED. At right hand side, you can see place. One LED we have placed. Okay. Now this one I have placed similar to. So at end of this session, I will share this PPT also so that you will be able to follow it. In same way, library. Now this one place. Where I want to place this push button. 10K register. So 10K register number is this one. This one is 10K register. Place. Okay, where I want to place this particular register? Here. Okay, so similar to this screen I am creating, and after that, this 330 register library, I am searching for that particular number, and this place 330 where I want to place at this particular point here. Okay, now we will shift, we will place here. Okay, so in this way we are creating. So this particular circuit, these components we have added. Now we will make connections. By which way we can create the connections? In this way. We want to create this circuit. This is our circuit, and depending upon the circuit, we will create the connections. Okay. First of all, we will link it with D2. So this one, D2 with LED and R2. This one, our wiring tool, D2 with LED. This one, R2. Okay, now we will make connections to this one to this 10K to 4, and this we will place to D3. Okay, so or we can take it separately. In this way. Now, okay, it is, this connection is ready, and this ground we will connect to R33. Ground to R33. This one. And this ground to 10K. Okay, only this part. Okay, so up to this point we want to create its file. No, keep this one. Yes, overwrite, and keep going. Apply. Okay, now we are placing it. this one, and so these we have not placed so far, so accordingly we can place it, okay, because these are outside. Actually in this particular screen zooming issue is there, so we can go for this floor planning. So accordingly we can set the gadget, these components, and now we can see this one, okay, so we can complete it. So currently some components are left, so but we can view by which way it will be looking. So this is our Arduino and the registers, push button, we want to give something via, okay, so particular dimension, we want to see some dimension, DRC check, Gerber file, okay, so this particular
DRC check will tell.
Sir, can you share how you make the Gerber file, sir?
Yes, sir. So you can see that here also you can create, okay, export this one and keep going, apply. So you can see generate PCB fabrication file.
Okay, sir.
Okay, so simply drag and drop these components, and once it is done, then generate Gerber file. Okay, generate Gerber. So this is created in downloads folder. So you can see these are the files. Okay, so yeah, just a minute. This is Gerber Arduino file. Is this visible?
Yes, sir.
This particular folder we have to send. We have to upload GTL file, GDL file, GBS file. So these are automatically created. So this ground, so one more ground we can link it. Okay, now is this okay?
पीसीबी पे प्रिंट लेने के लिए जैसे ब्लैक और व्हाइट पोर्शन जो करते हैं, मतलब अगर कॉपर पर जाके
हाँ वो इसमें हो जाएगा. Just a minute. For example, this particular canvas properties at right hand side you can set. Okay, convert schematic. So whatever things were left we have connected, and keep going. Copper layers, board outline, rectangular or round rectangular. What about radius? Apply, and now we will place it. We will go for floor planning. So this we want to place at center. This one we can see that connections are not breaking. Connections are retained. So wherever I want to place this connection will not be broken. It will be same. So I know that this particular circuit can be adjusted in small PCB also, in small board also. So we can change it. So you can see that this particular area is unused. So unused area we can optimize accordingly. So all circuits, all components we can place in this way, and accordingly this particular area can be optimized. Okay, or if we want to use entire area, that can be done. Okay, so in entire area we want to distribute these things, and here we want to place some message. For example,
how to change the number of layers of data, number of layers of the PCB.
Sir, can we resize the text size also?
Yes, yes, definitely. We can resize it. So you can see on click of this. So text at right hand side, this is font family, font management, rotation. And DRC check, it is fine. This is 2D view, and this is photo view, and in 3D view it will be visible in this way. So whatever registers we have placed, exactly same interface you will find in KiCad. So it's up to you whether you want to use KiCad or Easy EDA. So this is cloud based because it is easy to work, comfortable. Otherwise we have to download, install. Work is same. Okay, there is nothing, no new facility. Okay, so it is available on cloud. Even on your mobile phone also you can create circuit, because while you are traveling you want to view something, you want to edit something, so you can go for that. Otherwise we should be having access to our laptop.
How will be in the 3D view?
So simply this 2D and this one is 3D. So click on 3D view and you will be able to work on that. And if you want to go for its Gerber file, so pick and place. So all parts are available. One click, order parts. Okay. So place order, create BOM. And you will be able to order it. Export BOM file. But its price, you can see that its price is $0.02, $0.025. So in total, in less than $1, you will be able to get this PCB. If you want to change some point, you will be able to do. If you want to share it, for example, you want to share it, so you will be able to share. Okay. Edit project. If you want to, so you can see that rotation with R or with this one. So connection will not break. So wherever you want to place, you will be able to place it. Any type of device in library, lots of components available. For example, clock and timing, clock buffers. I want to edit it, place. So in this particular component, capacitor or audio products, buzzers, microphones, speakers. I want to use some speaker in this. So any of these we can take. This is extended part. So this is the speaker. At right hand side, you will see it's the circuit. Place. Where I want to place this. So here I want to place. Okay, just randomly I am placing its connection. And this one, so speaker is integrated. registers and this 3D view. So you can see this speaker is added. Register, LEDs, Arduino, and that one. How much it is looking difficult or easy to work with? Easy, very easy, very easy and user friendly. If you want to check go for DRC check, so click on DRC. Everything is given here. You can see DRC. Click on DRC. If there is no problem, in that case, it will move ahead. Okay. If you want to add Wi-Fi module, so that can be done. So you can see that connector, clock timings, diodes, electromechanical components.
Sir, is the
interfaces. Yes, sir, please. So sensors, RFID. If you want to work with RFID, RF detectors, antenna, RF antenna. Okay. So this is this one. Okay. Or RF attenuator. (2D), 3D, and you can see that this one RF attenuator is added here. And once it is ready, then its Gerber file can be generated. Once it is done, then generate PCB file Gerber. Click here and keep going. So folder will be downloaded and that particular will be able to attach. So any type of component. So you want to link amplifiers, sensors, different types of sensors. For example, you are working on some IoT project, gas sensors, so or thermistors, infrared sensors. Okay, place where I want to place. In this way. (2D view), this is 2D view, and this one 3D view. We want to change its parameters, its settings, we will be able to do it. Board color, in which color we want to order the board. So thickness, border thickness. Okay, CPCB. So this is a separate website. So here you can upload your Gerber file, whatever file you have generated, you can upload it and you can get its quotation in how much cost it will be fabricated. It will be manufactured by the plant. Okay, so you can work on these implementations. Very easy to use platform. If you want to work with KiCad, in KiCad also same thing is available. Okay, so if you want to use it for teaching and learning in standalone mode, you can use either KiCad ADA or Easy EDA. It is in standalone mode. Okay, so you can download it. So in same way you will be able to work. Okay, it is free and open source. Now, dear participants, I am sharing this presentation in which everything is recorded. Just a minute. Hello. I'm checking it. Just a minute, sir. I'm checking it. Yes, it is same. So, dear participants, now I'm sharing this presentation to all of you. Kindly confirm whether this presentation is downloadable or not. A link of this presentation I have given in a chat window. Kindly confirm whether this presentation is downloadable or not. And if you have any query, you can ask. Session is open for your queries. if you have any query, you can ask.
Hello.
Yes, sir, please. Piyush ji. Yes, sir.
Yeah. Sir, can you throw some light on double-sided PCB, how they can be made with this? Dual-sided, double-sided, in which both sides have component, that type of the PC we have seen.
Okay, actually, sir, currently we have used it's a standard edition. So if we are using that particular Pro edition or in that in KiCad, so in that you will get that particular feature. Okay, in KiCad documentation you will get that particular feature. So it is the basic scenario, how to create some particular components, how to put some components.
Okay. So the process will be likely same.
Yes, process will be exactly same. So you can use KiCad or its Pro edition. Its Pro edition is also free. That is also freely available.
Okay, sir. Thank you.
In this coverage, whatever we have covered, is this clear to all of you? Kindly confirm. And how much it is looking easy or difficult to work with?
Sir, is auto root option available, sir? So whether auto root option available or auto root option?
Yes, sir, all options are available. So if you want to work with multi-dimensional analysis, multi-dimensional fabrication, in that case, you can go for its Pro edition. So in that you will get so many other features. So it is the basic implementation that I have shown you, how to start with PCB designing, how to go for its fabrication. If you want to explore it, in that case, you can go for its Pro or KiCad. You can go for downloading and working with KiCad.
Sir, these third part. Okay.
Yeah, sir.
Please continue, sir.
Yeah, sir, my question is that there are many softwares available for PCB making, and few are charging very huge amount. So whether there is any limitation for making professional PCBs, or if we are going for the big size PCB, so whether any constraint which is associated with this process, because it is easy.
Sir. No, sir. Actually, when we go for PCB designing or this schematics, we have to take care of the components. Obviously, optimization part is the most important part. So we have to see in minimum number of components how we can implement, by which way we can design a schematic. And another thing is that in minimum size of board, in minimum area, how to put maximum required components. So that is the main thing. So in that particular scenario, you can go for evaluation of floor planning. Actually, this part comes under VLSI floor planning or PCB floor planning.
Okay. No, but after whether it has certain limits at higher level where some professional work goes on. This have you?
No, sir. There are no limits. There are no specific restrictions. So any type of schematic you can go for.
Because only I would like to know that whether if the work has been in advanced level, at that time if we will face certain issues which were not covered in this software. So whether to start from the scratch.
No, sir. Any
whether it is only for learning purpose like that.
No, sir. It is. So you can see that in Easy EDA, so millions of engineers are already using it. So you can see here. So it's
okay. Yeah. Otherwise, it is wonderful. Easy, very easy to use.
Yes, sir. You can see that in its official documentation. Also, you can see that around 4 million engineers they are using it. Okay. It is not only for teaching and students. So professional features are also available. And you can explore it. So project management and any type of complex diagram you can create.
Yes. Okay. Thank you.
So,
we will.
Any other query from participants? And how much it is easy to work with, how much it is difficult to work with, you can tell.
Sir, I wanted to ask, like when we are ordering this PCB, so they will give only the PCB printed or the components will also be there?
So it will be PCB. Basically, it will be a PCB.
Okay.
Not
This $2, $3 charges only for the PCB that they will be specifically designing.
yes, sir.
Okay. Thank you so much.
Otherwise, sensors individually they are very costly. So
we have to arrange separately.
yes. So if you want to check whether circuit is working or not, in that case you can go for simulation. In Easy EDA in KiCad, switch to simulation mode. So similar to Tinkercad, you will be able to simulate. You will be able to see whether output is coming or which type of waveform is coming. Okay, in simulation mode in KiCad or in Easy EDA simulation mode, you can check the output. So when you will create project, it will show switch to simulation mode when you will load it.
Excuse me, sir.
Yes, ma'am, please.
Sir, please share the link of your PDF file or presentation. Actually, my connection lost in between.
Yes, ma'am. Again, I have shared it. So you can download. Kindly confirm, is it downloadable or not? Simply click on this link and download. And kindly confirm, is this downloadable or not? Any other queries from the participants? Session is open for your queries. After that, we will conclude this session.
Excuse me, sir.
Separately, I will show you. Yes, sir, please.
Good afternoon, sir. Here in RGKT Basar, we have a PCB prototyping machine.
Okay, fine, sir.
What we do is like we take the Gerber file from Easy EDA and we'll convert it into G code.
Okay, fine.
We take that G code and use that G code along with that NVIS software, NVIS PCB prototyping software.
Okay, sir.
During that printing process, we are facing several issues, sir.
Okay, so you are facing issue in printing.
Printing, and one more thing, like when you are doing Easy EDA, we have seen like several, crossing of the lines. Is that will that be a problem, sir? Like crossing of the the connections.
Yes, definitely it will. So we have to take care of that floor planning part. So within that particular area, we have to optimize. So crossing of line doesn't matter, but it should be within the board. But no issue of crossing, no issue of that particular thing. I think you might be asking about that lines are intersecting each other's.
Yeah, exactly. Yes,
so no issue in that. Okay. So if you are working on some specific point, you can mail me. I will see what issue you are facing.
Yes, sir. Okay.
And there is one query that how to check circuit working. So to check the circuit working, we click on ERC DRC checking. So ERC DRC check will verify whether your circuit is correct or not, whether our connections are circuit are okay or not. Okay, or you can check it with simulation mode. When you will load Easy EDA new project, it will ask you to switch in simulation mode. In that case, you will be able to check the waveforms. So if you are working on some specific scenario, some specific points, you can mail me. My mail ID is given in presentation last slide. I will see. I will try to troubleshoot wherever you are stuck.
Thank you, sir.
So, dear participants, if there is no online question, then we'll close this online session and we'll have some discussion with our offline participants here. So if there is any quick question, then you can ask. And your assignment will be uploaded in Google Classroom only, as you are doing for the last 2 days. So kindly check your Google Classroom after 2:30 for today's activities. And I thank Dr. Gaurav for taking very interesting, informative sessions since morning. And I hope that you will practice at your place and do some informative projects using the knowledge shared by Dr. Gaurav.
Thank you, sir. Thanks to all participants.
Thank you.
Thank you, sir.
Thank you, ma'am. Thank you.